Hello everyone. I'll be talking about the sum and difference rules for even and odd numbers. Now, before I begin, even number is represented generally by 2n and odd is generally represented by 2n plus 1 or 2n minus 1 or simply 2n plus minus 1. And here n belongs to natural numbers, that is basically greater than equals to 1. And it makes sense because for a number to be even, it should be divisible by 2. That means all the even numbers must be a multiple of 2. So in this case 2n. Now for odd, 2n plus minus 1 or simply an even number plus or minus 1. Since even and odd numbers are alternate, even odd, in the natural number line, 1 is odd, 2 is even, 3 is odd, 4 is even, and like that. That means if you have any even number, that means the next number or its previous number will always be an odd number. And if you also have an odd number plus minus 1, it will also be even. Just a little note you can remember. So it makes sense that 2 and plus or minus 1 should be an odd number. Now, let's talk about even plus even. Well, we'll have 2n plus, well, I don't want to use 2n again because that will represent using the same number twice. So I'm going to represent it by another variable, letter m. So two different numbers, but yes, in some cases n can be equals to m, but don't worry about that. So I can take 2 common, n plus m. Now again, I have 2 into something. That means it is a multiple of 2. Meaning that this is divisible by an even number or simply divisible by 2 I meant. So this will make it an even number. So this is even. Now even plus odd. So again even is 2n plus odd number, I'll choose 2m plus 1. So I can take 2 common again, plus 1. Now here I have 2 into a number. So as we know from here, this is even. And we have even plus 1. That means this must be odd, as I discussed earlier. So this is in fact odd. Now what about odd plus even? Well, it is the same case as this one. That means we will have to follow this process again. That means just we'll get odd back. And for odd plus odd, we'll have 2n plus 1 plus 2m plus 1. You can also choose minus 1, but I prefer to use plus because it's easier to understand and do. So I mean in this case you can choose minus 1, plus 1 and minus 1 they can cancel, but let's do a bit something more interesting than that. So 2n plus 2m plus 2, right? 1 plus 1 is 2. That means we can take this whole thing common, n plus m plus 1, and like these cases we have 2 into some number. That means this is just an even number. So in fact odd plus odd is even. Now let's move on to differences. So even minus even. So in these similar cases you can have the chance of getting 0 when they're the same number, but let's take it as different numbers. So you will have 2n minus 2m. So if n equals to m, obviously you get 0, which is neither, I think, neither even or odd. I'll have to check that. It's a bit controversial, I think, but it should be neither. So either way get 2n minus m, and of course you can end up with negative numbers, but still negative numbers can also be even and odd, and in this case we get even. Now even minus odd. So it is 2n minus 2m plus 1. So it is 2n minus 2m minus 1. So 2n minus m minus 1. Now this 2 into something, it makes it even. Even minus 1, that means it's odd. So this is an odd number. Or you'll just get odd. Now odd minus even. It is in fact quite similar to this, but I'll just write it anyways. 2n plus 1 minus 2m. So just 2 bracket n minus m plus 1. So in this case we get an even plus 1. It doesn't matter minus 1 or plus 1, because in the end you'll just get odd number. Now odd minus odd. So you'll have, I'll write it here, 2n plus 1 minus 2m plus 1. So this is 2n minus 2m. 1 minus 1, this is just 0. So we can take 2 common, n minus m. And we again have 2 into some number, meaning that this is in fact even. And these are the sum and differences rules. So even plus even, even plus odd, odd, like that. And this is the proof, the algebraic proof. And if you learned something new, please like and subscribe. Thank you.